guys, so here we are with the first question of the exercise 1.1 for the chapter real numbers. So the first question is use Euclid's division algorithm to find the HCF of, and the numbers have been provided in part A, B and C. Before doing this question, let us quickly recap what we have learned in Euclid's division algorithm. Well, it says that if we consider the two unique numbers, say A and B, such that A is greater than B, then on dividing A by B, two unique numbers Q and R will be obtained, where Q is called the quotient and R is called the remainder. Then the relation between the numbers A, B, Q and R can be represented by using Euclid's division lemma as A is equals to BQ plus R. So now coming to the A part of the question, here we have been provided with the two numbers 135 and 225. Clearly, the number 225 is greater than the number 135. So in this case, A will be equal to 225 and B will be equal to 135. Now applying Euclid's division lemma over the numbers A and B, 225 can be written as 225 is equals to 135 into 1 plus 90. What it means is that if we divide the number 225 by the number 135, 1 is obtained as a quotient and 90 is obtained as a remainder. Clearly, the remainder obtained is not equal to 0, which means that we again need to apply the Euclid's division lemma over the numbers 135 and 90. Which means that now the new values of A and B will be 135 and 90 respectively. So applying Euclid's division lemma over the new numbers A and B, 135 will be equal to 90 into 1 plus 45. What it means is that if we divide the number 135 by the number 90, 1 is obtained as a quotient and 45 is obtained as a remainder. Again, the remainder obtained is not equal to 0, which means again we need to apply the Euclid's division lemma over the numbers 90 and 45. So applying Euclid's division lemma, 90 will be equal to 45 into 2 plus 0. Which means that 90 number is perfectly divisible by the number 45 as 2 has been obtained as a quotient and 0 is obtained as a remainder. As the remainder obtained is equal to 0, so division algorithm terminate over this step and the divisor of this Euclid's division lemma will now become the HCF of the numbers provided. What it means is that we can write the HCF of 135, 225 equal to 45. As 45 is the divisor in Euclid's division lemma when remainder turns out to be 0. So now coming to the B part of the question, here the numbers provided are 196 and 38,220. Clearly the number 38,220 is greater than the number 196, which means that A will be equal to 38,220 and B will be equal to 196. Applying Euclid's division lemma over these two numbers, 38,220 will be equal to 196 into 195 plus 0. Which means that if we divide the number A by the number B, 195 is obtained as a quotient and 0 is obtained as a remainder. As the remainder obtained is equal to 0, so Euclid's division lemma, or we can say Euclid's division algorithm, terminate over this step and the divisor will now become the HCF of the number provided. Which means that we can write that the HCF of 38,220 and the number 196 is equals to 196, which is the divisor of this Euclid's division lemma. So now coming to the C part of this question, here the numbers provided are 867 and 255. Here clearly the number 867 is greater than the number 255. So in this case, A will be equal to 867 and B will be equal to 255. Now applying the Euclid's division lemma over this number a and b, 867 will be equal to 255 into 3 plus 102. Which means that if we divide the number 867 by the number 255, 3 is obtained as a quotient and 102 is obtained as a remainder. As the remainder obtained is not equal to 0, so again we will apply the Euclid's division lemma over the number 255 and 102. So 255 will be equal to 102 into 2 plus 51. Which means that if we divide the number 255 by the number 102, 2 is obtained as a quotient and 51 is obtained as a remainder. So again the remainder obtained is not equal to 0. So now the new values of a and b will be 102 and 51 respectively. Applying Euclid's division lemma over this number, 102 will be equal to 51 into 2 plus 0. Which means that if we divide the number 102 by the number 51, 2 is obtained as a quotient and 0 is obtained as a remainder. As the remainder obtained is equal to 0, so division algorithm terminates over this step and the divisor will now become the HCF of the number provided. Which means that we can write the HCF of 867 and the number 255 will be equal to the divisor, which is 51 in this case. So this was all about the question first of the exercise 1.1. I hope this question is clear to all of you.